Hello everybody, Namaskar. Today we will discuss about edible coatings and films. In this we will see the definition of edible coating and the needs of this process, what is its mechanism of action, what are the different materials that are used for formation of coatings and films, then methods of coating and film application, and finally, we will take a few case studies of coating of fruits and vegetables. So, let us see what is edible coating. First thing, that primary purpose of food coating is to provide a barrier to microorganisms, to moisture, to gas and to solute migration in food. Okay. In fact, there are various coated fruits and are available in the market now. Edible coating is normally applied on food surface where a thin layer of edible film is formed directly on the surface or between different layers, and usually it is desirable that the coating should be edible so that the coated food could be directly eaten, but this is not a definite requirement. Even some non-edible material like wax etc. are even now also used for application of coating on the fruit surfaces, but there were certain problems related to that which we will discuss little later. So, that is scraping of this wax and there may be some interaction etc. So, that is there is a need to replace these non-edible materials as a edible films or coatings so that the fruit can be directly eaten, even coated fruits. So, one of the most well known coating procedure is the, as I told you, wax coating on fruits and vegetables, which is adapted to keep the product fresh, avoiding over ripening and moisture loss. However, the wax coating has certain problem not liked by consumers etc., that is sensory effect and other things are there. So, it is a need or now the replacement of wax is being done by the edible materials. So, then edible films, okay, these are actually a thin layer of materials coated or wrapped around a food product to act as a barrier in the surrounding environment. Okay. They serve as a carrier of natural or chemical antimicrobial agent, antioxidants, enzymes, vitamins and minerals. Okay. So, you can see here that is in the film that there is a polymer matrix, a plasticizer added into it, and homogenization is done, degassing etc. So, a homogeneous mixture of these film making material is used. Now, this material homogenized material is there is a one, it is a poured on a thin platform or surface and dried and you get a thin film, or in this solution, that is either by using spraying technology or such other technology, the fruit or vegetable is directly dipped into this solution, a thin coating is formed. So, it is basically the material is same, it may be the procedure may be different for application. One, you are getting edible film which can be wrapped, used for wrapping and application on the surface, or this by dipping method it is directly applied. So, this generally the edible films and edible coatings, they are synonyms to each other. As I told you, films are pre-formed separately and applied to food surface, are selected into edible pouches, are sealed into edible pouches, and the coatings are formed directly onto the food surface. Okay. So, why do we need edible coating and film? That is consumed, it is now the, because it is consumed along with the packed food, it is a green technology, reduces environmental pollution, extend the shelf life of food by the inhibition of the microbial growth, improvement in the quality etc. There is a it controls the diffusion rate of preservative substances from the surface to the interior of the food. It also preserves bioactive nutrients, it inhibits oxidation related processes, preserves phytochemicals and organoleptic properties of the food. It protects probiotic bacteria viability, carries that is antimicrobial or antioxidant etc. with it, and it is used in multi-layer food packaging materials also. So, here you see the mechanism of the edible coating, that is this it is a basically you can see this layer on the, it is a tomato on the surface of the tomato. This layer either in the form of film, it can be wrapped and then the film can be sealed, or by using appropriate method direct a very thin transparent film is made on it. So, it basically provides the barrier material, and the film properties etc. are properly selected, that I will come little later, but here you see that it is this thin film which is applied on it. It acts as a provides barrier to moisture, barrier to oxygen, even barrier to microorganisms etc. And in this coating various functional ingredient, antimicrobial ingredient etc. can be added. Okay. And it can be applied in such a way that it will improve the glass or transparency of the food, okay, and even it will provide barrier properties. So, that is how it regulates the in and out of the various agent gases etc. from the food into the food, and therefore, it controls the undesirable reactions, processes, even including respiration, and the shelf life of the food is increased. So, various drivers for the edible coating innovations include increasing consumer demand for ready to eat foods and fewer or no additive based food preservation, environmental issues such as recycling and biodegradability of the conventional packaging films, which is a problem or issue. So, that is to the great extent people want that the packaging material should be edible in nature. Changes in the retail and distribution practices associated with the globalization, even stricter regulatory requirements regarding consumer health and safety also act as driver for the edible coating innovations. So, the requirements for the edible coating, that is whatever the material that is film etc., that it should be its stability under high relative humidity, because the fruits etc. when they are stored in the environment, there may be relative environmental humidity etc. relative humidity may be high. So, the coating material should be stable under this. It should have a good water vapor barrier properties, efficient oxygen and carbon dioxide barrier properties. It should have a good mechanical properties. It should adhesion to the fruit, okay, pleasant to taste, that is the material which is used for application on the fruit. It should not interfere the organoleptic properties, taste of the, okay, it should be colorless, tasteless, physicochemical and microbiological stability, or the cost economically it should be viable, cheaper, and more importantly it should be a grass component, because the ingredient chemicals etc. which are used, they should be grass. The active edible coating, that you see that the active edible coating and non-edible active edible coating, that is active coating means here along with the coating emulsion, coating material, some active ingredient like antimicrobial, antifungals, antioxidants etc. are added into the emulsion which is used for making the coating or film. So, it becomes a that is a healthy approach. Okay. It improves functionality of the films, it increases the shelf life of the food, and it provides a high quality product which is even both fresh and safe. But the non-active coating, it just simply controls the O2, CO2 and water vapor permeations in and out. Okay. Raw materials generally which are used for making coatings and films, they may be polysaccharides like alginates, chitosan, gum arabic, pectins etc., starches like potato starch, corn starch, even cellulose derivative, carboxymethyl cellulose, methyl cellulose etc. Okay. Then some proteins like gelatin, casein, gene, okay, soya protein, whey protein, or lipids like resins, fatty acids, edible waxes etc. And it's some additives like there should be cross linking agents or emulsifiers, okay, 20 etc., or some plasticizers, so that that is when these polysaccharide, starches, cellulose, etc. protein when they are mixed or lipid when they are mixed together, it gives into a good emulsion, stable emulsion, and then some solvents like water, ethanol, acetic acid, etc. are used. So, these are the raw materials normally which are used are the ingredients from which these raw material can be, like it may be a fruit or vegetable extract which consists of water, pectin, dietary fiber, lipids, phytochemicals, pigments, phenolic compounds, etc. or plasticizer like sugar, glycerol or sorbitol. Okay. Plasticizer content may be controlled as it promotes reduced brittleness and stiffness, increased flexibility, stretchability and toughness, and which are all desirable, but it also impairs some film barrier properties. So, the level of plasticizer in the emulsion in the mixture should be properly controlled. Also, it should have some binding agents like edible polysaccharides, etc. to improve the consistency, mechanical strength and barrier properties of the film, and the functional as I told you earlier, that is to improve the sensory, nutritional, antimicrobial and antibacterial properties, antioxidant properties. So, the important thing, very important thing for the success of the technology, that proper selection of the edible coating material, because and its thickness and formation, because if the coating is too thick, which was generally a problem in the wax coating, etc., then the detrimental effect can result, because the internal gas concentration will be below a desirable level and the beneficial level are desirable and beneficial level, the proper gas concentration may not be obtained if the coating is too thick. So, it may be high or it may be low, and also there are certain associated increase in the carbon dioxide concentration which is above a critical level. So, these conditions lead to anaerobic fermentation, okay, if the thickness becomes too high. So, these can be remedied by developing several edible coatings, controlling the wettability of the edible coating material, measuring the gas penetration properties of selected coatings, measuring diffusion properties of skin and flesh of the selected fruit in which coating is to be applied, predicting internal gas composition for the coated fruits, and finally observing effect of this coating on quality changes on the coated fruits and vegetables. So, these are the 6 important factors which need to be considered while selecting edible coating material. Now, I will discuss about methods for edible coating. The common methods used for coating are either dipping, that is in the emulsion the material is dipped, or brushing, okay, spraying or wrapping. So, some other method like fluidized bed coating as well as pan coating or panning are also used. So, I will discuss briefly some important technology. First, the spray technology for the coating application. Okay. It consists of a set of spray nozzles, you can see here, which are used in the formation of fine droplets. Okay. And also there is a sprayer tank in which that the spraying material or coating material is added, and then also the tank will facilitate the liquid pressure. Then heating jacket nozzle for temperature control of the liquid before its injection, conveyor belt to move the product, data logger to control physical parameters such as pressure, temperature, flow rates, liquid level for the sprayer tank, and the air system to participate in both the production of droplet in the nozzle and the circulation of liquid flow. Here in the system you can see that yes, this is the sprayer tank. Okay. So, the material emulsion in the homogenized emulsion form, that is the coating material is here. So, from this with the help of associated pump, etc. Okay, there is a liquid set of valve, liquid strainer and liquid regulator and gauge. So, a calculated a control amount of that is this is flowed through these are the sprayer nozzle. Through this nozzle it is formed, and the food material it is on the conveyor belt it is coming. So, fruit so here it is a control rate, all right. So, from both the side, and it is ensured that a uniform coating is applied on the material. There are air regulator gauge, air setup valves and all those things are provided. Okay. So, now the obviously spraying pattern will improve if there is a increase in the operating pressure and increase in the fluid temperature, but the spraying pattern will deteriorate if the viscosity of the fluid is more. So, the viscosity or thickness of the emulsion is important parameter in controlling the spraying pattern. Okay. Then fluidized wet coating, here the coating material either in the form of a solution or in the form of a suspension is used. A set of nozzles are used to spray the coating material onto the surface of fluidized powders to form a cell type structure. So, it may be used for the smaller size vegetables like grapes etc., which can be easily fluidized. So, there is some arrangement that is the, and there may be three types of fluidization like top spray fluidized wet coating, where that coating material with the help of the inlet air, the fruit or vegetable or the material which is to be coated, it is fluidized in the air and then coating solution is sprayed over it. Okay, and air outlet. So, it is a top coating, or other is the bottom spray coating, that is the coating material is in the same direction to which air is going, the spray material or coating material is applied. And then third is the tangential spray fluidized wet coating, tangential from the middle, it is in the tangential direction it is coated. So, in generally used method is the top spray method. Okay. It is more popular in the food industry. Then pan coating, its process consists of depositing the product to be coated into a large rotating bowl, which is referred to as pan. Here the coating solution is then ladled on the sprayer onto the coating pan, here with the help of the nozzle, and the product is tumbled. Okay, it is moving, tumbled within the pan to evolve and distribute the coating solution over the surface of food material. Okay. So, forced air either ambient or at elevated temperature is applied to dry the coatings. Then composite coating. These are multi-component or composite coatings are usually made to explore the complementary advantage of each other component as well as to minimize the disadvantages of the coating. Most composite coatings associate a hydrophobic compounds like lipid etc. and a hydrophilic structural matrix. The composite films and coatings can be produced in two ways, either bilayer composite coating, the lipid forms a second layer over the polysaccharide or protein, or emulsion composite coating where the lipid is dispersed and it entrapped in the supporting bipolymer matrix. And you can see here that is it is by drip uncoated fruit and then dipped into this solution, then washed, again dip into the other solution, washed. In the process, that is a multiple layer is applied over the fruit surface. Okay. Method for formation of the edible film. There are two methods generally used. Okay, film formation, either solvent casting, that is known as wet method, or extrusion, that is dry method. So, in the wet methods, it involves the dispersion or solubilization of the polymers in a solvent medium prior to film formation. See, like earlier we discussed, so that is all the ingredients, they are taken in the form of a homogeneous solution, and then this homogeneous solution is applied layer by layer deposition method, or even solvent casting. That layer by layer deposition method is generally popular in the laboratory scale or a smaller scale, but in the industry you see here that is this film here, it is from the film dope, it is poured on a moving thin plate, okay, and it is dried with the help of some air, that is hot air etc. ambient air. So, it is slowly dried and the material is rolled. So, that is a wet process. In the dry process, that it involves hot press molding or melt extrusion process of powdered polymer. Here you can see here in the figure it is sold, either thermoform films using or injection molding etc., or even simple extrusion are used for making these films. Now, let us see very important properties like gas permeation properties of the edible coatings, that is the permeability of the O2, CO2 and H2O can be calculated as P is equal to Qx by AT delta P, where P is the permeability of the gas, it may permeability to either O2 or CO2 or H2O. A is the area of the film, T is the time, delta P is the partial pressure difference of the gases across the film, and X is the thickness of the film. And success of edible coating for fruits and vegetables depends mainly on selecting films or coatings which can give a desirable gas composition that is appropriate for a specific product. Okay. And there are two very important characteristics here, wettability and coating effectiveness. Effectiveness of coating depends primarily on controlling the wettability of the coating solutions, which affect the coating thickness of the film. Edible coating formulations must wet and spread on the food surface uniformly, and upon drying they should form a coating that has adequate adhesion, cohesion and durability to function properly. Wettability of a solid by a liquid is determined by the balance between adhesive forces, that is the WA of the liquid on the solids, and cohesive forces WC of the liquid. So, WA causes the liquid to spread over the solid surface, while these cohesive forces WC cause the liquid to shrink. So, a proper balance between these WA and WC has to be said, and that is called equilibrium spreading coefficient WS, and it is defined as that WS is equal to WA minus WC, or in other words is equal to YSB minus YLB minus YSL, where YSB, YLB and YSL are the solid vapor, liquid vapor and solid liquid interfacial tensions. And the WS, that is equilibrium spreading coefficient, will always be either negative or a 0, negative value or a 0. So, here in this figure now we will take up that is some examples of fruit, that is here in this figure you can say modified chitosan based coating material, that is on the strawberries coated with modified chitosan based formulation containing limonene and other emulsifiers, that after 10 days, that is control sample how it happened, and then after 16 days and after 21 days these coated with having limonene and having no limonene, you can see the effect. Similarly, ready to eat vegetables, they are coated and how their appearance looks like, that is even some cases some coating material is made in such a way that you cannot by your naked eye, generally you will not be able to even distinguish, find out whether it is coated or not. So, preparation of edible coating material and its application on tomato, I will take a case study, that is here the millipore water is used, and in this sodium alginate is added with the continuous stirring, okay, and then keep the water bath maintained at 72 degrees Celsius for 30 minutes, stir it regularly and until the solution becomes crystal clear. You get the sodium alginate is fully dissolved in water, you get a solution, okay, then add glycerol into it and stir it again. And then here that is there are some other, this is a formulation developed in my laboratory, there are some other ingredients are also added. So, you get a clear cut homogeneous edible coating emulsion in the emulsion form, a thin emulsion form. So, these tomatoes, they are taken, washed, then dipped in the coating material for about 5 minutes, and this is allowed the coating to dry at room temperature, and then it is packed in LDPE zip locked pouches and stored at 10 degrees Celsius temperature and 90% relative humidity. Okay. And we have found in our study that the coated tomatoes, you can see that after 48 days of storage at 10 degrees Celsius and 90% humidity there, and when this coated tomatoes that is stored along with that coating, the atmosphere temperature, that is it was controlled, that is in the control atmosphere unit they were kept. So, here, that is in the normal atmosphere it was kept for 48 days, but in the control atmosphere, along with the coating, O2 CO2 composition of the gases environment was also controlled. The shelf life increased up to even more than 2 months, that is 65 days. Whereas you can see the figure that uncoated tomatoes, they spoil even after 15 days, 10 to 15 days of storage at 10 degrees Celsius and 90% relative humidity. So this is the things. Even control atmosphere storage we will discuss separately in the next class. This is a rice starch and Carnation coating of banana, and you can see that the coated uncoated banana, that is the ripening stage. Okay, uncoated banana, that is ripens fast, whereas after coating its rate of ripening is decreased, means that is its shelf life is extended. Similarly, here that you can see that image of the control fruit and the coated fruit. Then percent this is of utilization of pulp. Okay. Here the ethylene production rate or respiration rate of the banana with the storage time, and in all cases you can see even the ethylene production rate as well as respiration rate in the uncoated material is that is high, and in the coated is less. So means that is coating is working here, that is a starch and carnation based coating material on banana, it is giving good result. Okay. Also edible coating, that is a composite coating based on corn starch and plasticized gelatin, that is the glycerol or sorbitol, was applied onto the red crimson grapes to extend its shelf life. Coated grapes had improved appearance after storage for about 21 days under refrigerated condition, and also had a lower weight loss compared to the control grapes, you can see here. Also that is the mung bean paste, in that pomegranate peel was added at different concentrations, and this coating was applied on the fruits. It was found that the mechanical properties, reducing power, antibacterial activity, antibacterial attributes of mung bean protein film considerably improved by adding pomegranate peel. Okay. This is a comparison between edible coating and active packaging, that is in work done in my laboratory, and we have found that in the case of banana active packaging, that it was shelf life was found up to 33 days at 30 degrees Celsius temperature and 80% relative humidity, whereas the control could last only for 5 to 6 days. Okay. Whereas edible coating, that is it was much more, that 56 days even at 25 plus minus 2 degrees Celsius and 80%, and control was 1 week. Similarly for guava, the similar result you see 32 days and 40 days, and for tomatoes it was about 65 days and 49 days, right. So that is giving much more, that is here 65 days is edible coating along with that is the packaging along with the control atmosphere storage. So these are the result data to show that there is a significant improvement. So now let us discuss some of the problems associated with the edible coating and films. As I told you earlier, that is modification of the internal atmosphere can increase disorders associated with the CO2 or low O2, that is waxing of apple and pears. This is the problem. Ripening and respiration rates are inhibited, but because of the thickness etc., and inside maybe some more concentration of alcohol. So anaerobic fermentation was reported in some cases, and the alcoholic flavors developed, okay, in some of the apples and pears which were coated with wax. Apple coated with sucrose fatty acid ester had few detrimental changes in terms of fruit firmness, yellowing and weight loss, but had increased incidence of core plus. Tomatoes coated with 0.6 mm gene film, protein film, produced alcoholic flavors. Also color change, loss of firmness, ethanol fermentation, decay ratio, weight loss of edible coated fruits and vegetables are, that is, important quality parameters, and they are all mainly depending upon the thickness etc. of the coating material. So, wax and sucrose fatty acid esters are most widely used coating materials. Consumers dislike wax coating which impart waxy taste, and there is a need for developing alternative coating materials that do not impart waxy taste, and that is the thing which we have discussed, that is many edible coating materials are developed. Effect of edible coating, however, on internal gas composition and its interaction with quality parameters must be understood, must be determined properly. Then self-healing edible coating, that is, it may so happen that edible coating may become damaged during application, during transportation or during storage, and once the coating is damaged, there is increased risk of exchange between the components in the fruit and the environment. So, the damaged surface may become an area for microbial growth and thereby negatively impacting the quality of the product. So, the coatings are fabricated by by layer application of chitosan and sodium alginate formed by 3 assembly cycles etc. to ensure that if there is any damage etc. so that it is self healed. So, the mechanical properties and the water and oxygen rates of the healed coatings were found to be even 97% or 67% and 95% respectively, and this is shown how they are again, that is the, and its reference of this is also given here. So, finally, I will summarize that yes, edible coatings are very important technology as far as the shelf life extension of fruits and vegetable is concerned, and even this is such a simple technology that it can be applied, it can be used even at a household level or local level also, that is fruits, vegetables etc. after proper washing, all right, and cleaning etc. They can be either using some brush or some spray painting devices or by just simple dip they can be for it, but however this formulation as well as the process, that is how long it should be dipped and how to ensure that it should be properly ensured that a proper coating is maintained, so that and it has a proper permeation properties, permeability etc. to gases, and it can extend the shelf life. So, these coated materials at the household with extended shelf life, they can be easily transported, sent to the processing unit or in the market etc., and this becomes a good substitute of the replacement of the wax coating which is at present done. But and even in this way that even some of the functional ingredients etc. can also be added, and the coating may be functional coating or active edible coating etc. can be applied. So, these are the references which are used in this lecture. Finally, I thank you very much for your patience hearing. Thank you.